with one equation at a time. Okay, and we start by identifying the OA and the RA for that one equation. Then we arrange them into two columns. So we always have OA's on the left, RA's on the right. Let's look at an example here. So we've got, so they're showing us three equations here, and we've got a few different metals reacting. So we're just going to, the first step is just pick one equation. It doesn't matter, it doesn't have to be the first one, but just pick one equation and start with that. So we're just going to work with one at a time. Identify the OA and the RA. So if I look at the first equation here, and I look at cobalt-2 ions reacting with solid indium, which of those is going to act as the OA? It's going to be the cobalt ions. The indium is the RA. So that's our first step, is just identifying which is the OA, which is the RA. Then we look at the result of the reaction. Did it react? Well, here they're showing us products. So obviously we formed products in the reaction. It was a reaction that took place and it was spontaneous. So if the reaction is spontaneous, then remember the OA has to be above the RA. So we always do OA's on the left, RA's on the right. Make sure to always leave space above and below because you don't know where the other reactions are going to fit in. So the OA, the cobalt-2 plus, has to be above the RA, which was the solid indium. So I have to show this OA above RA in my table. Once we put them in the right place, then we just complete the half reaction. So cobalt-2 plus will be reduced to form cobalt solid. The corresponding OA for indium, what's the charge in indium? 3 plus. 3 plus. And then just balance out the charges by adding the electrons. So we're always showing these as reduction half reactions because the OA's are on the left side. And remember, oxidizing agents are reduced. Okay, so we've looked at the first reaction and we've put our first two half reactions on our table. So the other ones could fit in above, between, or below these. We don't know yet. Reaction 2, we've got copper-2 plus reacting with solid cobalt. So here, the copper-2 plus is my OA. The cobalt is the RA. Was the reaction spontaneous? Did we see a reaction take place? Yes, we did. So this means, again, that the OA has to be above the RA. So see where we can fit this in on our table. I already have solid cobalt in the table, so I need to put copper in relation to that. Because it was spontaneous, the OA has to be above the RA. So I'm going to put copper-2 plus above solid cobalt. So my copper-2 plus needs to go above the solid cobalt. And then we complete it by filling in the rest of the half reaction. So the corresponding RA, solid copper, and balance with the electrons. Now we want to look at our final reaction. We have copper-2 plus reacting with solid palladium. This time they didn't even show what the products are because there weren't any. Okay, no reaction took place. It was non-spontaneous. So this means that the OA has to be below the RA for non-spontaneous. Okay, my OA is copper-2 plus. My RA is solid palladium. So where's this going to fit in on our table? I already have copper-2 plus on my table. The palladium, the RA, has to go above this. So it needs to go at the very top of my redox table. Big charge on palladium, Pb2 plus 2 electrons gives us solid palladium. And we're done. Okay, we've now created our table. Remember that the strongest oxidizing agent is at the top of the table, so they go up in increasing strength. The strongest reducing agent is always listed at the bottom of the table. So these are in order of increasing strength going down. If the question asked you to, let's say, maybe they wanted you to list the reducing agents in order of decreasing strength. First, you got to find which side of the table the RAs are on, and then we have to know that the strongest is going to be in the bottom right corner. So if we list these in decreasing strength, it means we're going from the strongest to the weakest. Strongest would be solid indium, and then